Chapter E is another nomenclature chapter where we're going to learn how to name alcohols, amines, ketones, and aldehydes. And then after this, we have one more nomenclature chapter, chapter F, and then we will be done with the nomenclature. So as we approach this chapter, you just have to remember all the rules that we've learned up to this point, that they all pretty much apply. And in this chapter E, we're just adding to it. Okay. I know it's a little daunting. There's all these rules and regulations, and I'm just keep on adding more and more. But that's the nature of the beast. So the compound, name of a compound now, excuse me, is going to require a suffix added to the root. Now, typically when we looked at something like this, we would ask ourselves, what is the longest continuous carbon chain? And we would call that the parent name, right? But now we can look at this, and parent name and root name kind of are like the same idea. So if we looked at this molecule here, we would say, hey, the root is a hexane, right? Because there's 6 carbons. So that's the root, or the parent name. It becomes a root when we start putting on a functional group that is not a halogen, a nitro group, an ether, alkene, or alkyne. So if these are the only types of substituents on a carbon chain, then we call that a parent chain. If there's something other than these that are in this sentence here, and some examples would be a carboxylic acid, an ester, an alcohol, or a ketone, the parent name is now considered a root. So let's put on a functional group here to show you what I'm talking about. So how many carbons are in the longest continuous chain here? Well, we see that there is 5 carbons. 1, 2, 3, 4, 5. So the parent, or the root, would be pentane. That's the root. Now we have to add a suffix to that root in order to tell us that we have an alcohol. So if we go here to this table here, we find the functional group that we're interested in, which is an alcohol, and we look in this column right here labeled the suffix. There's something called a prefix, which we'll get to in a moment, but we look for the suffix and it will tell us to add this name to the root. So we see, let's see here, it tells us to put an OL, an all. So that right there is the root. So I'm going to square the root. And then the suffix, I'm just going to underline, and that would be the all. Okay. So each different type of functional group has a different suffix. Oic, oic acid, oic anhydride, oil chloride, amide, nitrile, al, one, all, and amine. Now the prefixes is going to tell us where the substituents are. Okay. And we've already discussed how to name certain substituents. But if the substituents are one of these kind of functional groups, then we name those substituents by a different name or a prefix. So if we're looking at an alcohol prefix, it would be a hydroxy. If it's an amine, it would be amino. And an amide, it would be a carbamyl. So you're going to have this chart in front of you as you're taking the exam and needing to name these types of molecules. So you don't need to put this into memory. It will be in front of you. So what we do are we are going to apply all the rules that we've learned from chapters A and B and C to this chapter. Okay, so let's go through these bullet points one by one and show you what they're talking about. Okay, I know this isn't the biggest font, so you can't see things very well, but you can read along in your textbook. So let's take a look at a molecule. Okay, so there's our molecule that we want to name. So bullet point 1 says determine the highest priority functional group that calls for a suffix. So I see here I have an alcohol and an amine. Because I have two different functional groups, I need to figure out what the suffix I'm going to use. And the way we get to choose what suffix we're going to use is we compare the functional groups. And I said we had an alcohol and an amine. And you can see these numbers in blue. They're ranked in priority. So if you have the smaller number, that means it's higher ranked and it will trump anything below it. So this molecule that we have here, the suffix is going to be an -al, because we see that an alcohol is above the amine. So we know our suffix has to be an -ol. So if I want to look at it this way, suffix equals the -al. Establish the main chain or ring as the one that contains that highest priority functional group. So we've already identified the alcohol as the highest functional group, so we need to find the longest continuous chain that has that hydroxyl directly attached to it. And we can see, and this is an easy problem, that that's our longest continuous chain. And we can see that it has the hydroxyl directly attached to it. The third point says we need to remove the E from the ane, ene, or eine ending and add the corresponding highest priority functional group name to it. So when we look at this, how many carbons are in that longest chain right there? There's 5. And so bullet point 3 is telling us that we would normally call this pentane, right? And then we would have to add the suffix. But we have to eliminate the E. So it would actually be called pentanol. Okay? We have to remove that E off of the ane. So we got rid of that guy. Now, this fourth point, it says that nitriles are an exception to this rule, we will cover that in chapter F. So let's not worry about nitriles for right now. So now we have to number the chain or the ring that gives the highest priority functional group the lowest locating number. So we could number it 1, 2, 3, 4, 5. And we see the highest priority functional group is a number 4. Or we could have numbered it this way, 1, 2, 3, 4, 5. And clearly the blue numbers win because it gives us the highest priority functional group with the lowest number of 2. The next bullet point says we add the locator number for the highest priority functional group immediately before the suffix. All right. So what that's saying is, where is this all? Where is it located in the pentanol? And we can see that the all is referring to the hydroxyl. And what carbon is it attached to? The second one. So we would have to put in that locator. So we have the pentane dash 2-all. Pentane 2-all is the name of the molecule. Oh, but we're not done yet, right? Because we have that last bullet point. All other functional groups in the molecule are treated as substituents and appear in the name as a prefix. So we observe that we have an amine right here. And every other substituent is going to be named with a prefix. So we have to come back here and see, hey, we have a amine in our molecule. And then we look at the prefix column. And we see that amines have a prefix of amino. But where is that amino substituent located? It's on carbon 4. So we would just go 4-amino. Well, let's get a little bit closer here. So the entire molecule's name is 4-amino pentane 2-all. So let's just label everything here. That right there is our root. This right here is our suffix. And this right here is going to be our prefix. So this slide's telling us that different functional groups are ranked based off priority. That's what I've already shown you. So you just got to look at those blue numbers. The carboxylic acid takes the highest priority. The amine takes the lowest priority when you are naming molecules with these substituents on them. Now here's some examples of some alcohols. We see the propane 1-all. We've located the longest continuous carbon chain. There's 3 of them. That's why we have the propane. And we see that the functional group is an alcohol, so we add the OL. And the numbers here are telling us the location of that molecule, or the hydroxyl group. Now this one's a little interesting in the fact that you don't see a number 1 between the N and the O. And the reason why is because if I renumbered, if I would have redrawn this molecule like this, do you see how the numbering always has to start where the hydroxyl group is? It has to. So it's just redundant. When you only have 2 carbons and you have an alcohol, it's going to start at the carbon 1. So it's just redundant. And the same thing with cyclohexanol. If that's the molecule, there's only this substituent attached, and we know that's going to be priority 1. Here's some examples of amines. Right. And you can see in these examples that here's the root, right? 5 carbons, so pentane, but we've dropped the E, added the location of the amine. It's super important that you drop that E in the name, okay? And it's also important to be able to look at this table and identify the suffix, which is our amine right here. Now let's take a look at when you have a substituent with an alkene or an alkyne. So in this particular example right here, what is the root? We see that the root is going to be the cyclohexene. All right. And then where's the suffix? The amine. And what's this chloro? This is just a prefix / the substituent right there. Let's see here. This molecule right here. You see that there's 7 carbons long. That's where we get the hepta. We also see that the hydroxyl group is on carbon 2, so that's why you see the 2 all. And then we have 2 alkenes, and we need to specify where those locations are. Let's see. And because we have 2 alkenes, we have to add the di. And the 4,6 tells us where those alkenes are, and the 2 tells us where the alcohol is. So very straightforward. The only thing that we're adding now that's different is the suffix. Now let's take a look. Let's go and name this guy, and let's walk it ourselves through it. Okay. I want to show you my process of solving these, naming these molecules. Okay. First thing we need to figure out, really, what is the highest priority functional group here? We have chlorines. Those don't matter because those are halogens. But we have an alcohol and amine. And we know from the previous examples, amines take the alcohols take the priority. So that means our suffix has to end with an "all." And then I look for the root. And the root has to have the alcohol attached to it. And I see that we have a cyclohexane ring. That's not a D. Let's see here. So there's our root. Do we have any prefixes? Well, I see that we have 2 amines and 2 chlorines. So we know that a prefix for an amine is an amino right there. So we have an amino And how do we talk about chlorines? We know those are chloros. We want to add location numbers. So we have to start with the highest priority functional group. So that's carbon 1. And then you want to give all the other substituents the lowest possible locator numbers. So we go clockwise in this particular case. And now we make sure that we can identify where those functional groups are. The alcohol is on carbon 1. The chlorines are on carbon 2. And the amino groups are on 3 and 4. Now we just put this all together. So we put the prefixes first in the name, but we have 2 of them. How do we decide which one we write first? Alphabetical. A comes before C. So we go 3, 4 dash. How many amino groups do we have? 2, so we need to specify that by the di amino dash. What else do we have here? We have 2 chlorine groups. 2-2 or comma dash di because there's 2. Chloro. So we've taken into account all our substituents and the prefixes. The root is cyclohexane. That is an X. But remember, we have to drop the E. And then we have the all. Now, why did I not go -1 all? Because putting that 1 right there is redundant. Because when we look at the parent or the root, we see it's a cyclohexane. And so we have to have the hydroxyl group labeled as number 1. So we don't need to put this 1 in here because we already know it has to be the first. Okay? So that's the whole name for that molecule right there. Now what happens when you have 2 highest priority groups in the molecule, shown right here? We see that we have 2 hydroxyl groups. So they are the highest priority. They beat out an amine, right? So when we see more than 1 highest priority functional group that's the same, we keep the E. So the root right there is the pentane. So that's our root. The all is our suffix, but we had to add the di because there's 2 of them now. And then the amino, 5-amino, is simply our prefix. How do I exit that? So that's our prefix. So when you have more than 1 of the same functional group, you keep the E. All right? Now let's take a look at this molecule right here. So let's draw another molecule. Okay. So what's the challenge? What do we do first? Well, we need to look at all the functional groups in the molecule and find which one's the highest priority. We see we have an ether and an amine. Now the ethers don't make it on the list. When you come back here, you see that it doesn't make the list. And so it's one that we don't have to worry about because we've already gone over how to name ethers. But we have an amine. Okay, so now that's going to trump it. So our amine is our highest priority functional group. So that means we know our suffix has to be an amine. If you go to the table, you'll see that that is our suffix. Okay. Now, what is our longest chain of carbons that the amine group is attached to? And we can see that we have this chain right here, 1, 2, 3, 4, 5. And I numbered it from left to right because I wanted to give the amine the lowest priority locator number, or the lowest locator number. So since I see there's 5 carbons, then that would make the root, what, pentane? Right? But now what's interesting, what we're introducing in this particular problem is all the amines that we've looked at previously, you can see, have 2 hydrogens attached to them. 2 hydrogens on that molecule, 2 hydrogens on that molecule. Now look at this one. We have an ethyl group and a methyl group. So no more hydrogens. So how do we name that when there's alkyl groups coming off of the nitrogen? So that's our next principle that we're going to learn. Now when you have other alkyl groups on the nitrogen, you're going to treat those as substituents. Okay. And the way we name those, much like let's go back to something that we're familiar with. How would you label that substituent? You would say, hey, that's attached to carbon 3, and I know that substituent is called a methyl. So when the alkyl groups are attached to the nitrogen, we see there's another methyl. But how we number it, per se, is you use the letter N. But this letter N is behaving like a number. So this N-methyl is telling us that we have a methyl group attached to the amine. But I have a second alkyl group attached. So you just write what it is. We see it's 2 carbons, so that would be a ethyl. But it's an N-ethyl. So those N's are helping us locate where those substituents are. So we've accounted for this one, that one, this one. We have one left, that guy. And we see that is attached on carbon 5. And we know from naming ethers that is a methoxy. So we have 4 substituents, or you could view it as prefixes. Now we just put all the pieces together. So prefixes go first, but they need to be alphabetical, right? So we can clearly see the winner or the first one for sure, has to be the N-ethyl, because E comes before M's, right? So we just write it down. N-ethyl. Let's see here. What's next? So ethyl's done. So we have 3 left. So we have to do a dash. So how do we break this tie? We have 3 M's. We just keep going. M, 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 E, 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 T, 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 H, 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 Y, Y, O. So that breaks the tie. So we have 5-methoxy. Wait, I forgot my dash. So I got that one done. Now between the last two, what do we do there? We always just stick, because those are both methyls. One's attached to the root and one is attached to the nitrogen. We just put the nitrogen first. Now we're treating this nitrogen as a number, so we're going to treat it like such. So numbers are separated with a dash, and we have a nitrogen or a methyl on the nitrogen, and we have our third methyl. And how many methyl groups are there? 2, so that makes dimethyl. What's the root name? Pentane. But we have to drop the E. And then the amine is attached to carbon 2. And there's the name of that molecule. It's a mouthful to say for sure. N-ethyl 5-methoxy N3-dimethyl pentane 2-amine. But it's really cool. You should be able to take this name and draw that based off of those pieces. This slide is telling us that when you have a stereocenter, you need to specify in the name, at the very beginning of the name, you put it into parentheses. And we can see in this problem we have 2 stereocenters at carbon 2 and carbon 5. And we have an alkene, which we need to specify if it's an E or a Z. And so when we look at all this, we can see that we just put them in numeric order, 2, 3, 5. And we just put what the stereochemical outcome is and the configurational outcome, E or Z. And we just put it, and then we name this part right here, just like we've been doing throughout this whole lecture. So let's shift our attention to naming ketones and aldehydes. So let's take a look at this guy right here. Okay. We see the longest carbon chain is 5. We also see that we have an alcohol and we have a ketone. If we go to our table, we clearly see that a ketone is above an alcohol, so the ketone takes precedence. So that means that the suffix has to be the -one. It's not pronounced one, it's pronounced -one. And so there we see, right here in the name, there's the suffix. The longest continuous chain is numbered in blue, and we see that the ketone is attached to that longest chain. And we numbered it from right to left because we wanted to give the highest priority functional group the lowest locator number. The root is right there, the pentane. Do you notice also how the E is missing because we've dropped it? And then we have an alcohol. But notice when we're naming the alcohol, when it's not the highest priority, we're not using the prefix all or the suffix all. For an alcohol, if we're looking for the suffix, it's an all. But if the alcohol is behaving as a prefix or a substituent, it's called a hydroxy. So we see that this right here is named 4-hydroxy, and that is our prefix. Now when we look at this molecule, the third one here, what's interesting about this is we see that we have 2 ketones. And what happens when we have 2 functional groups of equal priority? The rule states that we keep the E. And I didn't draw it to there. The E is retained. Very, very important to see that. Now let's take this molecule, the first one that we named on that slide. Okay, we already named that molecule. What if I changed it to an aldehyde? Okay. So what's the highest priority functional group between the alcohol and the aldehyde? Well, if we look at the table, we see an aldehyde is above an alcohol, so that takes priority. So that means our suffix has to be an al. So the suffix is an al. The root, let's see, would have to be 1, 2, 3, 4. So we have butane. What about a prefix? It's the same as above. That's a hydroxy. What carbon is that hydroxy attached to? Number 3. Now we put this all together. We find our substituents and our prefixes. We only have 1, so it's 3-hydroxy. Butanol. Now, why did I not put a locator number? Why did I not do this? Well, because aldehydes are unique in the fact that because they have this hydrogen right here, it is impossible to have an aldehyde in the middle of a molecule. Because this guy right here will never be an aldehyde because there's 2 alkyl groups attached to it. So aldehydes are always going to be on the end of a molecule. And so if the aldehyde is the highest priority in the molecule, we know it's going to be on the end, and the highest priority carbons get number 1. So it's just redundant. We already know that the aldehyde, this suffix right here tells us we have an aldehyde. We already know the aldehyde's going to be on carbon 1. So we don't need to show the number or the location. If we take a look at this one, we see that we have 2 aldehydes. Okay? You see that they're both on the terminus of the carbon chain. Now this one's interesting because I could have found a larger chain. I could have went like this. I'll show you. I could have numbered it like this: 1, 2, 3, 4, 5. That's the longer chain, but we didn't choose the longest chain because we have two functional groups of equal priority. So the longest continuous chain had to contain those two functional groups. That's why we only have the butane, even though we have a chain of 5 carbons. Also notice that we've kept the E because we have two of the same functional groups. And then we have the di to tell us that we have 2 aldehydes, and the Al to tell us what functional groups we have in the molecule, which are aldehydes, right? But we can also see again that we're not writing it out like this. We're not with the parent name or the root. We're not going butane dash 1,4 dash dial. We're not doing that because it's redundant. The butane tells me that there's 4 carbons, and it's telling me I have 2 aldehydes, and aldehydes have to be on the ends of the molecule anyway. So we already know that the aldehydes are going to be on carbon 1 and carbon 4 because that's how aldehydes work. Now, if you get a cyclic aldehyde, it has a very special name that you just have to remember. So there's the root, the cyclopentane. See that we keep the E. The E is retained when it's cyclic. And then we just go cyclopentane carbaldehyde. So we add that. Okay. So that right there is kind of like the root / suffix all in one. Okay. When you have a cyclic, or you have an aldehyde that's attached to a cyclic molecule here, it's called a carbaldehyde. Okay, we've encountered trivial names for a lot of molecules in chapters A, 7b, or chapters A7 and B4, sorry. And ketones and aldehydes, amines and alcohols also have common names. You don't need to memorize these, but you should be aware of them. Like when you talk about isopropyl alcohol or rubbing alcohol, what is its IUPAC name? Propane-2-ol. Ethanol, we call it ethyl alcohol or grain alcohol. That's what's in alcoholic beverages. We call this benzyl alcohol. You know, these are just common names that as you are in the field long enough, you just know and you just have them memorized. Okay? But you don't focus your attention on memorizing those. But what you do need to be able to do is to identify if the alcohol is primary, secondary, or tertiary. This is a critical skill in order to being able to learn the reactions that we're going to learn. So let's draw 3 alcohols here. So we need to be able to identify the degree of alcohols that we have here. And the way you do that is you identify the carbon that is directly attached to the hydroxyl. So we see it's attached there. Then we ask ourselves, how many carbons are directly attached to the one in red? And we see that there's only 1. So we have a primary alcohol. And we just do the same analysis. That's the carbon that's directly attached to the alcohol. How many carbons are directly attached to the red one? 1, 2, secondary. And then you just follow suit, and we can see that there's 3, so that's tertiary. Super important to know how to identify those. That, I can promise you, will be on the exam. But it's not going to be these very nice and simple looking molecules. It's going to be more complex looking species. Here's some trivial names for some amines. Okay. But the takeaway from this slide is you need to be able to identify a primary, secondary, and tertiary amines. And there's also even a quaternary amine. Okay. And I want to show you how to figure that out. So let's draw ourselves some amines. All right. So when naming amines, what you do is you just count how many carbons are directly attached to the nitrogen. So we see that there's only 1 carbon and then 2 hydrogens. So since it's only 1 carbon, that's primary. In this one, there's 2 carbons directly attached to the nitrogen, so that's secondary. Tertiary, and quaternary. You need to be able to see that. Here's some trivial names for aldehydes. This is a very famous one. If you're in anatomy labs or physiology labs, you might be smelling this if you're looking at cadavers. This is what the chemical that we stick on biological tissue to keep it from decomposing. And this stuff works very, very well. In my undergraduate degree, I was in a chemistry class, and they brought out probably like a 15-week baby that was aborted, and they stuck the whole baby in this jar of formaldehyde. And this baby was from the 70s, and it was just perfect. Like, nothing was wrong with it. It wasn't decomposing. It was just perfectly there still. It's very weird and amazing how formaldehyde does that. It just totally pickles you, really. Trivial names for ketone. You'll see acetone a lot in the lab. That's a good solvent for cleaning things. That's also a component in nail polish remover. And that is the end of Chapter E.